Okay, hello. Today we are going to work on the math skill that is simplifying fractions to their lowest terms. Simplifying fractions to their lowest terms. So you can see the question asks to simplify the fractions. It's a very direct, straight to the point question, and it gives me all of these different fractions that are not in their lowest terms. Now, what does that mean, simplify the fractions? And what do I mean, lowest terms? Well, I want to give you an example to start off with. So let's move this out of the way. I want to show you two pieces of pie. I've got one full pie that has been cut into 4 slices, and I have another pie exactly the same size, but it's only been cut into 2 slices. It's been cut right in half. Now, both of these pies are the same size. The whole pie is the same size. The only difference between them is that one has been cut into 4 slices, one has been cut into 2 slices. So, if I ate half of my first pie, I'm going to color it in. I ate this slice here, and I decided, oh, that was too good. I have to have another piece. There we go. I have eaten half of this pie. If I wanted to phrase that as a fraction, I have eaten 2 slices out of the 4 that would be the total. So this numerator tells me how much I've eaten, how much is the fraction in question, and the 4 denominator tells me, well, how much would one whole pie make up? How many slices make up one whole pie? So I've eaten 2 out of 4 of the slices of pie. Well, the next day, I find that there is a different pie in my fridge. Somebody has been leaving me mysterious pies, and I'm not complaining. I go ahead and I just eat half of that pie. It's only been cut in 2, and I'm not going to eat the whole thing. I'm not that hungry, but I'm going to have one of these nice slices. I can phrase this as a fraction. I've eaten 1 slice out of 2. The pie has been divided into 2. 2 slices would make up the whole. That's what the denominator is asking us. The denominator is telling us how many slices would make up a whole pie. Well, here it's 2, and I've eaten 1 of them. That's my numerator, 1. Now, my question for you, which value is higher? On what day, day 1 or day 2, did I eat more pie? And I'm sure just by looking at it, you can see I have eaten the same amount of pie on both days, even though the fractions are different. So over here, I ate 2 out of 4 slices of pie, and over here I ate 1 out of 2 slices of pie, but it was the same value. It was the same amount of pie total. And that's because 2 out of 4 and 1 out of 2, these two different fractions, are equivalent. They are equivalent fractions, equivalent. And you can see that root word, equal, equivalent. They are equal in the sense that they have the same value. The only difference between them is that 1 out of 2 is a more simplified version of 2 out of 4. It's more like direct and to the point. This is as simple as we can imagine a representation of half a pie being. We could cut this into even more slices if we wanted to. If this was the case and I ate this pie, well, it wouldn't be 2 out of 4. It would be 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8. 4 out of 8. In this case, I've eaten 4 out of 8 pieces of pie. That's still an equivalent value to 1 out of 2. 1 out of 2 is just the simplified version. It's the version in lowest terms. I can't get a fraction representing this value any more simply than 1 out of 2. So, when my question asks me to simplify these fractions, it's asking me to find an equivalent fraction to something like 6 over 30 or 4 over 40 or 6 over 8, whatever the question's asking. Find an equivalent fraction that's as simple as it can possibly be. Well, how do we do that? Well, I can see that we've got 6 out of 30. I'll make it nice and big so I can work with it a bit better. 6 out of 30. And the way I simplify this fraction isn't by drawing these as pies and dividing it into 30 slices and then trying to see how I can imagine that a bit more simply. I'm actually going to use my multiplication table for this. Now, if I want to be ultra technical, the way that I would find the simplest form of 6 over 30, the lowest version of 6 out of 30, I would find the greatest common factor, the G, C, F between 6 and 30. But that would involve me doing some factor rainbows. That would actually involve a fair bit of work. It would get me there in one step once I did all that work, but that kind of defeats the purpose if you do a ton of work just to save a little bit of work on a couple extra steps. I'm actually going to get there a little bit easier. So, using my multiplication table, which hopefully we've memorized. If we haven't memorized it, hopefully we've gotten it, tattooed on the back of our eyelids, so we're never ever without it. Having the multiplication table at your fingertips, whether that's in your brain or in your desk, is going to make your life so much easier. So always have one of these ready to go. We're going to use our multiplication table to find 6 out of 30 in its lowest terms. And the way we're going to do that, we are going to find a single number, one number, that divides into 6 and divides into 30, and both results are whole numbers. Now, what do I mean by that? That means, what kind of number can I think of that I can do 6 divided by that number? I can also do 30 divided by that number, and both results in non-decimal, in a whole number. Well, I can think of immediately one of them, because these are both even numbers, and we know that even numbers always divide evenly by 2. So if I do, let me change my color, I'm going to do 6 divided by 2, and I'm going to do 30 divided by 2. I have to do the same to the top as the bottom, and the bottom to the top. I can't change this number as I go down. If I do it to the bottom, I have to do it at the top, and vice versa. Well, 6 divided by 2, that's going to give me 3. 30 divided by 2, that's going to give me 15. So, this is definitely lower terms. The question is it lowest terms? Is this lowest terms version of the fraction? Can I think of any number that I can divide 3 by and end up with an even number, and I can also divide 15 by and end up with not an even number, I'm correcting myself, a whole number? Can I divide 3 by a number and end up with a whole number, and 15 by the same number and also end up with a whole number? Well, let's consult my multiplication table. I want to find both of these numbers, and I want to see if they have any similarities on these outer lines. So I'm going to look through here. Well, I can see my 3 right here. 3, I can see that 3 can be divided by 1. 3 can be divided by 1, and it'll give me a 3. But also, 3 can be divided by 3, and it'll give me a 1. Okay, so I'm going to keep that in mind. 3 can be divided by itself, or 1. Now let's look for 15. Well, no, there's 15 right here. 15 can be divided by 5. Okay, it'll give me 3. And, oh, look at that. 15 can be divided by 3, and it will give me 5. So I remember, 3 can be divided by 3, and it'll give me 1. 15 can be divided by 3, and it'll give me 5. So that means the number I want to divide both by and end up with a whole number is going to be 3. Because I can see on my multiplication table, well, 3 can be divided by 3 here, and 15 can be divided by 3 here. So let's see what that gives us. I'm going to switch back to my red pen. 3 divided by 3, and 15 divided by 3. Well, what does that give us? And is it in lowest terms? Well, 3 divided by 3, 3 fits into 3 once. 15 divided by 3, that gives us 5. Is this lowest terms? Can I divide 1 by anything to end up with anything lower than 1? Nope. I can even check my multiplication table. 1 divides by 1 gives me 1. 1 divides by 1 gives me 1. Once I have a 1 up here, I'm in my lowest terms. So the lowest terms of the fraction 6 over 30 is 1 over 5. And I did that in 2 steps, but using my multiplication table, it wasn't so bad. Wasn't so bad. Well, let's see if I can do that in even fewer steps. Still using my multiplication table. I am not going to do number 3. I'm going to move in order. Let's move this over. Let's do 5 over 10. Simplify the fraction, 5 over 10. Well, let's find 5 on my multiplication table. Here we go. I have it right here. Here's 5. Well, 5 can divide by 1, and that'll give me 5. Or 5 can divide by 5, and that'll give me 1. Okay? So far I'm feeling like I don't see any more 5s on here. So far I'm really only feeling like 5 can be divided by 5. Let's check out 10, right below it. 10 can be divided by 2, but look at that. 10 can also be divided by 5. Well, that's awfully convenient because I know 5 can be divided by 5. So let's divide both by 5 and we'll see what we end up with. 5 divided by 5, 10 divided by 5. What is that going to give us? 5 divided by 5 is 1. 10 divided by 5 is 2. Look at that. We've got a 1 in our numerator. I know that I can't, bring it into any lower terms than 1. 5 out of 10 is the same as 1 over 2. And if I wanted to, I'm never going to ask you to do this, but it's nice to just be able to prove it to ourselves. I can show you what this looks like. 1, 2, 3, 4. I'll give it. It's not the nicest looking pi, but it'll prove my point, I think. 1, 2, 3, 4, 5, and 1 out of 2. We can see that these are equivalent fractions if I fill them in. 1, 2, 3, 4, 5, and 1 out of 2. Not my most attractive pies, but the point stands. 5 out of 10 is an equivalent fraction. It's the same value to 1 out of 2. And we found that just using straight math. We didn't have to draw anything. We're just drawing this to prove it to ourselves. We used our multiplication table. So you can see that the math is true. The math does work. Let's do a couple more, and then I'll leave you to your own devices to do some of these on your own. Okay, let's do number 3. Number 3 asks us to do 4 over 40, okay? Lowest terms, 4 over 40. Well, let's go on here. I can see 4 can be divided by 2, and that'll give us a 2. 4 can also be divided by, 2, and that'll give us a 2. Now, I see another instance of 4 here. 4 can be divided by 1, and that'll give me 4. And 4 can be divided by 4, and that'll give me 1. Okay? So I'm keeping those in my brain. So far, what I'm remembering is 4 can be divided by 4, 1, and 2. Those are the 3 numbers that I'm keeping in my brain. Let's look for our other number. Let's look for this 40 right here. Where do we see 40? Well, it should be around our 10s. Now, there we go. There's 40. 40 can be divided by 10, which we haven't listed yet, so it's probably not helpful, but look over here. 40 can be divided by 4. 40 divided by 4 gives us 10. And we remember, 4 divided by 4 gave us 1. So both can be divided by 4. Let's see if that brings us down to lowest terms. Red pen, divided by 4, divided by 4. 4 divided by 4 gives me 1. 40 divided by 4 gives me 10. We've got a 1 in our numerator. That's lowest terms. There we go. 1 out of 10, lowest terms. Okay, I want to do one more. Let's make it a hard one. 24 out of 30, 99 out of 108. Let's do that. That's a weird looking one. 99 out of 108. This one right here, number 8. Okay, so we're going to look for both of those numbers. I might even write it down if I'm working directly. Let's see. I'll make a nice little box. When we're working with these weird numbers and it's hard to keep them in our brains, I'll make a little box for 99. What can 99 be divided into? And I'll make a little box up here for 108. What can 108 be divided into? And once we have a matching number, well, then we'll know that that's probably our best bet. It's worth a try. So, 99. I'm going to look in my multiplication table for 99. There it is right there. I see it. 99 can be divided by 9 and 11. Okay, 99 can be divided by 9 and 11. So I'm going to list them actually. 9 and 11. Those are the two numbers that 99 can be divided by and give us a whole number. Now let's look for 108 and see if we can match any of these here. 100, oh, there it is, 108. 108 can be divided by 12, and it can be divided by 9. Okay, I'm going to list those. So it can be divided by 12, and it can be divided by 9. And immediately I see what these two things have in common. Not that 11, because there's no 11 over here. 108 can't be divided by 11 and give us a non-decimal, a whole number. Not that 12, because 99 can't be divided by 12 and give us a whole number, so let's cross it out. But look at that. Both can be divided by 9 and end up with a whole number. So that's probably our best bet. I love it. 99, let's try it. 99 divided by 9. 108 divided by 9. And we'll even use our multiplication table to find these answers. You know, if you've got a calculator handy, then you can use it, I suppose, but we've memorized our multiplication table. You know this stuff. You guys can do this stuff. And if you don't, then have your multiplication table handy, because the more you use it, the more it lives in your brain. And I want this to live in your brain. 99 divided by 9, I'm going to look. 99, I track it up. Yeah, 99 divided by 9 gives me 11. Okay, 99 divided by 9 gave me 11. And 108 divided by 9. 108 divided by 9 gives me 12. So 99 over 108 in probably lowest terms gives me 12. Now, it's always nice to check. Let's check if this is lowest terms. Because, you know, on our first step, it might not be. There might be an additional step to do. It might not have, we might not have found the greatest common factor. Now, I think we did, but it's worth checking. You know, usually when we end up with one of these prime numbers, an 11, it's usually a lowest terms fraction. But let's give it a check first. Let's check out our 11. We'll see what 11 divides by. So 11 can be divided by 11 or 1. Okay, 11 and 1. That's what makes it a prime number. It can only be divided by itself or 1. And let's look at 12. If 12 can be divided by 11 or, well, 1 isn't really going to get us anywhere. 1 isn't a great factor. It's just going to end up with the same fraction. So can 12 be divided by 11? There's 12. Can it be divided by 11? It can be divided by 12 or 1. Here's another 12. 6 or 2, 4 or 3, 3 or 4. No, you know, 12 has a lot of factors, but none of them are 11. One of them's 1, but I'll show you why it doesn't matter that one of them's 1. I mean, anything can be divided by 1. Doesn't help us. 11 divided by 1, 12 divided by 1. Well, what does that give us? Does that bring us to any lower of terms? 11 divided by 1 is 11. 12 divided by 1 is 12. So look, we've ended up exactly where we started. There's no point. It didn't bring us to lower terms. We can divide by 1 all day. We can divide by 1 till the cows come home. It's not going to change our situation. So 11 over 12 is, turns out, the lowest terms of, the lowest term, lowest version of 99 over 108. And we found that using our multiplication table. That's probably one of the trickier ones that you'll get. Something like 18 over 90, you know, even 18 over 90, we could do it pretty quick. 18, I'm going to list those factors that I can find here. What can 18 be divided by? What can 90 be divided by? Well, I'm going to check for 18. It can be divided by 9. It can be divided by 2. It can be divided by 6. Can be divided by 3. So 9, 2, 6, 3. And of course, like if this went high enough, you could say, well, Mr. Vaughn, 18 can be divided by 1. Yeah, it can. Anything can be divided by 1, but it doesn't help us here. So you don't really need to list it. You can, but it's not going to help you. Don't bother dividing by 1. And what about 90? 90, well, I can see 90 here. 90 can be divided by 10, and 90 can be divided by 9. And racking my brains, do I see another 90? I do. I see 9 and 10. Those are the only 90s I see. 10 and 9. So, 10 and 9. What do they have in common? Well, they have that 9 in common. So 9 is going to be our dividing number. Let's do it. 18 divided by 9. 90 divided by 9. 18 divided by 9. Let's look over here. If we don't have it memorized, use it. 18 divided by 9, 2. 90 divided by 9, 10. Now here's an interesting one. This is indeed an interesting one because it looks like we didn't find our greatest common factor. So this is what I was warning us about. Now, 2 over 10, definitely lower terms than 18 over 90. But is it lowest terms? No, it's not lowest terms. 2 can be divided by 2 or 1. 10 can be divided by 2 or 5. I can divide both of these by 2. That's why it's always important to check. Did I say I can divide both of these by 5? I meant to say I can divide both of these by 2. 2 divided by 2, 1. 10 divided by 2, 5. Now I'm in my lowest terms because I ended up with my 1. 5er. 1 over 5. 18 over 90 in its lowest terms is 1 over 5. You can see how more simple this looks. When I'm asking you to simplify the fractions, 1 over 5 is so much easier to picture than 18 over 90. I can picture a pie that's been divided into 5 and has 1 slice eaten. Definitely I can. I can't picture a pie that's been divided into 90 and has 18 slices eaten. I can't picture that. This is what we want. Simple fractions, useful fractions. Now, this video went too long. I'm sending you on your own devices. Go give this a try. Give it a go. Good luck. You got it.